Hello everyone, this is Khairul Alam Shobuz from All Math Matters. Welcome to my online math class. So today we will learn very important topics from function, and I think this is so important for maths and as well as for the maths D, because each and every exam if we look at the previous question, domain and range are the common question. So first of all, in my lecture, I'll try to give you the complete idea what is domain, then what is range, and finally we'll evaluate some problems and find the domain and range from functions. Okay, first of all, look at what is domain and what is range. So let's say a function f is such that x map to x plus 2. This is a function. Okay, now what will be the domain and what will be the range of this function? Okay, first look at, we can write this function as like that, y equal x plus 2. So here the value of x is called domain and the value of y is called range. That means input of this function is called domain and output of this function is called range. For an example, if we take some value for x, if we take x equal 1, then from function we can get y equal 1 plus 2, that is 3, and if x equal 2, then we'll get y equal 2 plus 2, that is 4. If x equal 3, then y equal 3 plus 2, that is 5. So look at here, these are the sets of value x and these value are the sets of y. So these value are called domain and these value are called range. So if we look at the set of domain equal 1, 2, 3 and the set of range equal 3, 4 and 5. So this is the input, that is called domain of this function, and this is the output, which is called range of this function. So you can use any value and you can input any value as a value of x and then we'll get the output, which is the value of y. So domain is the value of x, that is input is called domain of a function, and after keeping this value in this function, then we'll get range and that's the value of y. So this is the domain and range of a function. Now we can consider another example for finding the domain and range of a function. So here if the domain is given, then we can easily find the range of a function. Okay, for an example, f is a function such that x map to 3x square negative 1, and here the domain is defined, that is x greater or equal to. That means here already the value of x is defined, actually the domain is given, this is the domain. Now question is, what will be the range of this function? So you just input this value and that should be more or equal to. So if we take the least value of this interval, that means if we take x equal to, input this value of this function, then we'll get f of 2 equal 3 multiple 2 square negative 1. If we calculate that, then we'll get 3 multiple 2 square means 4 negative 1, 3 4s are 12 negative 1 equal 11. That means the minimum value of this function will be 11. So the range of the function will be greater or equal 11. So we can write, because the value of y is called range, or you can write is like that, greater or equal 11. So here the range will be greater or equal 11. So this is the range of this function. If the domain is defined, then we can find the range quite easily. But question is, if the domain is not defined, then how we can find the range of this function? Okay, now we will learn this domain and range. If the value of domain is not defined, then how we can find the domain and range from a function? Okay, by using only 5 tricks, you can easily find the domain and range of a function if the domain is not defined. Okay, so tricks 1, that is rule 1. Okay, let's say f is a function, x is mapped to 3x over 2x negative 1. This is a rational function. For any rational function, we can find the domain and range. So we know that in rational function, the denominator cannot be 0. So if the denominator is 0, then the function will be undefined. So now we will find for what value of x the denominator will be 0. So here the denominator 2x negative 1 must be not equal 0. By calculating this, we can find the value of x. So 2x not equal 1. That means x not equal 1 over 2. That means half. That means for only x equal half, the function will be undefined. That's why the domain of this function is all real value. That means x belongs all real number such that x not equal half. That means the domain will be all real number except half. Okay, now question is, what will be the range? So we already know that the inverse function. So by finding the inverse of this function, then we can find the range of a rational function. Okay, now what will be the range? So for finding the range, first we will find the inverse of this function. Okay, let's say y equal 3x over 2x negative 1. So you just calculate and find the value of x in terms of y. So if you cross multiply this, then we'll get y into 2x negative 1 equal 3x, or 2xy negative y equal 3x. Okay, we can take the x in the same side. So 2xy negative 3x equal y. we take the common x from this both, then 2y negative 3 equal y. So x equal y over 2y negative 3. So look at here, the denominator is 2y negative 3. So same thing for range. So we know that the denominator cannot be 0. So 2y negative 3 cannot be 0. So if we calculate 2y cannot be 3, that means y cannot be 3 over 2. So for any value of x, we cannot find the value of function is 3 by 2. So the range of this function is all real number except y not equal 3 over 2. That means if we put any value of x, we cannot find the value of y as a 3 by 2. So the range of this function is all real number except 3 by 2. So in that way, we can easily find the domain and range of a rational function. Number 2 is if the function is square root. So let's say f is a function x is such that x map to root over x negative 1. So we know that inside root the value cannot be negative. So for what value of x the function value will be negative, we just look at this. So we know that this value cannot be negative, that means it must be positive. So here the inside value of this root, that is x negative 1, must be positive, that means greater or equal 0. So by solving this inequality, we can get x greater or equal 1. That means the domain of this function will be the domain of this function will be greater or equal 1. So what will be the range? So look at here, the minimum value is 1. So when we find the range of a square root function, so we just put the minimum value inside this function. Then what we'll get if we put x equal 1 inside this function, then what we'll get f of 1 equal root over 1 minus 1, that is root over 0 equals 0. That means the possible minimum value of this function is 0. So the range of this function, so that is the domain. Okay, now range of this function will be greater or equal 0, or you can write if y is the range, then y is greater or equal 0. That means all positive value which is greater 0. This is the range of this function. So in that way you can find the domain and range of any square root function. Okay. Now I'll show number 3, the rule 3. The rule 3. If the function is logarithmic function, that means if the function is like that, f such that x map to log x plus 1. So here this is a logarithmic function, so we know that the log does not take any value which is 0 or less. So that means inside log the value must be positive. That means here the value of x plus 1 must be positive. not equal 0, because if you put 0 inside log, that will be undefined. So must be positive, that means must be greater 0. So if we solve this inequality, then we will get x greater -1. So that means the domain of this function will be -1 to plus infinity. So the domain of this function will be -1 to plus infinity. So what will be the range? So keep in mind, for range of logarithmic function, the range could be any value. That's why the range is all real number. In logarithmic function, the range could be any value. That means the range is all real number. So in that way, you can easily find the domain and range from a logarithmic function. Okay, next, rule 4. If the function is exponential function, that means f is a function is such that x map to e power x, or it could be 2 power x, or anything power x, that is exponential function. So if it is exponential function, then what will be the domain and range? So for exponential function, the domain is always all real number. That means for all real value of x, the function will be defined. That means the domain of this function is all real number. So now what will be the range? Okay, so the range should be, so what will be the possible value of this? So the range should be 0 to plus infinity, because if we put any value for x, it cannot be less than 0. This is exponential function, it cannot be less than 0. For any value of x, it is always greater 0. That's why the range is lies between 0 to plus infinity. Okay, now the last rule. If the function is modulus function, that means absolute value of this function. So rule 5. So if it is modulus, that is f is a function x such that map to x plus 1. Okay, now what will be the domain of this function? So we know that inside this modulus all value should be positive. That means we can take any value for x. So here the domain should be always R, all real number. That means any value of x. The domain of this function should be any value of x. But what will be the range? So we know that inside this modulus it is always positive. So if it is like that, if it is -1, it should be +1. If it is -2, it should be +2. That's why look at, for any value of x, it cannot be negative. So what will be the least value of this function? That is 0. So the range of this function will be 0 to plus infinity. This sign is means equal. It's a closed interval. That means equal 0, 0 to plus infinity. So the range of this function is 0 to plus infinity. That means for any value of modulus function, for any modulus function, the domain is always all real number and the range is 0 to plus infinity. So in that way you can find all domain and range of this function. So if someone practice these all 5 rules properly, then you can easily find any domain and range of any function if the domain is not defined. But if the domain is defined, then you can easily find the domain, because domain is defined, so you can easily find the range. So if the domain is not defined, by using these 5 rules, you can find most of the domain and range of this function except trigonometric function. So thank you everyone.